Alright, so an overall chapter summary of chapter 4. We've learned that covalent bonds are formed by the sharing of electrons between atoms rather than by the complete transfer of electrons from one atom to another, as we learned for ionic bonding. These two shared electrons are a single bond. 4 would constitute a double bond, and 6 electrons that are being shared between two atoms would constitute a triple bond. So each bond shares 2 electrons. The group of atoms then that are held together by covalent bonds is called a molecule. So you'll typically see the term molecular referred to when you're talking about covalent bonds. We also saw that when we have lone pairs of electrons on an atom, that you can have a coordinate covalent bond that would be formed if that entire lone pair is going to help sit and form a bond with a vacant orbital from another atom. So that's a coordinate covalent bond. And then we saw that when you're forming covalent bonds, that an atom shares enough electrons to reach the noble gas configuration, whether that's 2 electrons for hydrogen or typically 8 electrons for all of the other elements. Although we did see some notable exceptions to the octet rule in reaching a noble gas configuration. We saw that things like sulfur and phosphorus that have empty d orbitals, they can have electron expansion and they can actually reach higher states than the noble gas configuration in their outer shell. We also saw that things like boron will only form 3 bonds and never reach their noble gas configuration because they just don't have enough electrons in their valence shell to start with to reach that noble gas configuration. So there's notable exceptions to this octet rule. Molecular formulas then show the number and kinds of atoms in a molecule, and we learned how to draw Lewis structures, how to calculate formal charges, and try to get the best structural formula representation of a molecule. And so that's its most common resonance structure. So we also learned the term resonance structure. And then our covalent bonds are going to be indicated as lines between the atoms, and the valence electron lone pairs are shown as dots when we're drawing out our Lewis structures. We also learned that bonds between atoms are going to be polar if the bonding electrons are not shared equally between the atoms. And this is determined by the electronegativity difference. So the ability of an atom to attract electrons is called electronegativity, and it is highest in the upper right of the periodic table and lowest on the lower left. Our molecular polarity, remember, is the sum of all the individual bond polarities and lone pair contributions within the molecule. And so we can see that we could have polar bonds within a molecule, but it doesn't necessarily mean that the overall molecule is polar. It has to be the sum of all the different bonds that are involved. Then we saw that molecular compounds usually have lower melting points and boiling points than ionic compounds. And this is due to the strength of attraction of the two molecules. If you've got full charges where you've got donated electrons and accepted electrons, these are much stronger interactions, and they typically will form molecules that have much higher melting points and higher boiling points. And then we end with the different key words that you should be familiar with from this chapter. And that is chapter 4.